So first we're going to prepare our solution that goes in our dialysis tubing. So we're going to start with dextrose. Dextrose is the common name for glucose. You can see it's something that you can buy in the grocery store. It's a sweetener. It's simple for the body to use, and of course, as we know, glucose is a natural source of energy. So we're going to put that in our solution. We're also going to put starch in our solution. Remember, as you can see, this is something that you buy in the grocery store. It is a more complex carbohydrate, so think about sort of the types of carbohydrates that we are looking at in the solution that's going inside of our dialysis tubing. So I'm going to prep that solution first. And what I'm going to need to do is to use our scale to measure out our material. So we're going to start with dextrose, or glucose, I should say. So I'm going to zero my scale, and that's about 13 grams. I don't need to be super precise because this isn't chemistry, but we have about 13.6 grams. So I'm going to set that aside as our measured glucose. Next, I'm going to measure out our cornstarch. And we need much smaller volume, or much smaller mass of cornstarch in our solution. There, perfect. So that's about how much starch we're going to need in the solution. So I'm going to set that aside. And instead, we're going to prep our glucose solution and sucrose and starch solution in a Erlenmeyer flask. And to do that, we're going to need a volume of distilled water. I've got some distilled water right here. This is what we're going to use to dissolve our material. And the first one I want to combine is the glucose solution. So I'm going to take our measured glucose, and then I need to measure out our volume of distilled water, and we're going to need 75 milliliters. So I'm going to measure out 75 milliliters of distilled water using a graduated cylinder. This graduated cylinder can measure up to 50 milliliters, so I'm going to need to use it twice to get the volume that we need. In order to dissolve our glucose best, I'm going to use a stir bar, drop that in there, and I'm going to put the whole thing on our stir plate, which is right here. And this is going to allow us to mix our glucose into our distilled water. What I want to do now is I want to measure the amount of glucose using glucose testing strips in our solution. And this will give me a measure in milligrams per deciliter, which is a really typical volume measurement, mass measurement per volume in medical measurements. And these glucose test strips are used usually for people who have dietary issues centered around blood sugar to test the glucose concentration of food that they might be eating. So I'm going to do that with our solution. Here is one of the test strips. It's just a plastic strip with a sort of a litmus test at the end, which will change colors depending on what our solution is. And dip it in and pull it out. I'm going to wait a few minutes while it saturates the testing strip to see exactly how dark it's going to get. The test is usually about 3 minutes for water-based solutions. Okay, so our timer is done. I turned down the brightness on the video a little bit so that you can see just how much our test strip has changed. And I'm going to use this scale on here to sort of determine what my concentration is. That looks a little too light, still a little too light. So I'm going to say we're right around 300 milligrams per deciliter. And I'm going to make sure that I record that volume, 300 milligrams per deciliter. So that's the concentration of glucose that will be in our solution. The last thing I'm going to do to prep the solution is I want to put our cornstarch in. As you can see, our cornstarch is a little bit difficult, having difficult time dissolving down. So we are going to put it back on the stirring plate to make sure that we mix in that starch as much as we can to get it to dissolve as well as possible. Now you can see your solution is more opaque than clear. It's because the cornstarch will not completely dissolve. But this is the solution that we're going to use. I also don't have a method for measuring the concentration of cornstarch, but we could calculate on knowing exactly how many grams that we used, which was 0.9 grams, and exactly how many liters of water here, which we actually have 75 milliliters of water. So we could do this concentration of starch. But you'll see why we measured the glucose concentration in just a moment. Okay. The next step is to prepare our dialysis tubing. What I'm going to do is take the tubing out of the water where it is dissolved, resting, and I'm actually going to tie an end to make a little bag. So I'm going to do this on camera so that you can see it a little bit clearly. Use my finger, just like tying the end of a balloon. Now that I've got that knot, I want to make sure it's nice and tight. So I'll pull it as tight as I can. Great. So basically I have a little sack with one end that is knotted. And what I want to do is I want to open the other end of the dialysis tube. This is tricky, but with enough practice, you can open it. Sometimes I like to use a pipette to sort of help me put some air into it in order to get that bag open. Great, perfect. So I'm going to measure a small volume of our solution that we prepared using a small graduated cylinder. And then I'm going to pipette that volume into our bag, and then I'm going to take the mass. Now I want to get that volume into here. So what I'm actually going to do is pipette directly into this bag because it's sort of the easiest way to get the volume into the dialysis tubing, which is a little bit tricky. I'm going to stop there because I actually don't want this tubing to get too full, but as you can see, I've sort of been able to pipette about 10 milliliters into the bag, and I'm going to tie off the other end. So I want to make sure that both ends are tight. Great. Perfect. So I'm going to give it a rinse just to make sure. There, and that's what we have. So it's like a little candy full of glucose and starch. Now I'm going to take the mass of this. So we're going to go back to our scale. And I need to record this mass. Okay, 10.31 grams is the mass of our bag. Great. I'm going to turn this off. The last thing I need to prepare is a volume of distilled water with a way to measure starch. So we need to be able to measure the starch. Remember, we didn't do that in the last step. We didn't measure the starch concentration inside the bag, even though we know we put about 0.9 grams per 75 milliliters into the volume. But we want to make sure that we are measuring starch in both parts of the lab. So the one way that we can do that is to use Lugol solution. Lugol solution is iodine-based, potassium iodide base, an iodine base, and it is able to turn a specific color when it interacts with starch solution. Keep in mind that there are warnings for this. So in the lab, if you were to work with this, you would have to use gloves, and we would request you not pour it down the sink. But I'm going to use a very, very small volume, just a drop or two, and I'm going to put that into our 250 milliliter beaker of distilled water, and you'll see what color it is once we do that. If there was starch in this solution, we would see a blue color, but we don't. We see orange, which indicates to me that there's no starch in our distilled water solution. I'm going to close that. What we want to do is just make sure we get an initial concentration of glucose in our beaker before we put our dialysis tubing in it. So just like we did last time, I'm going to take the test strip, I'm going to set it in and start a timer. And leave it and allow it to give us an indicator of how much material, how much glucose there is in our distilled water and Lugol solution. Okay, and we'll look at it, and hard to see under here. Turn the brightness down. We don't really see any. It's pretty yellow. and so it's low on the glucose volume, which is unsurprising. And what we're going to do is we are going to take our bag, which we know is full of glucose and starch, and we're going to put it into our solution of distilled water with glucose indicator. And so we should be able to tell if starch leaves the volume of the bag, because in that case we would see a blue color outside. And we should be able to tell if glucose leaves, because we're going to be able to measure the final glucose concentration of our distilled water. But here's what I'm going to do. So I'm going to keep my bag, I'm going to put it into my solution, and then I'm going to allow this to sit for about an hour. And we'll come back in an hour and we'll be able to see sort of what happens to it over time. Alright, and we are back to get the measurement on our dialysis tubing. So we are going to need our scale right here. And we're going to need to be able to take it out of the solution and see if we've had any net movement of any of our materials. So first of all, I'm going to take it out. I'm going to examine it. I want you to know that it feels very full compared to when we started and it was quite loose and baggy. Now it sort of feels very full, looks much more like candy. And remember, we started with a mass of 10.3 grams. And so we'll see what has happened to the mass of the bag over time. I'm going to pat it down a little bit just to get any excess water from the outside off, because it's really the volume of material inside the bag that we're most interested in. Okay, let's put it on our scale. And now we see that our volume, which started off as 10.31, has increased to an initial, that was initial volume 10.31, final initial mass 10.31, final mass 12.33 grams. Final. So it has increased in mass over time, and that's unsurprising to me because of the change in bag. Now, what is the other important thing that we notice here? We have greatly increased the volume of the bag, so it's more turgid, and we have changed the color. Remember, our initial color was almost like a whitish, and now we see blue. And what did we say was possible blue indicator in this? The Lugol solution. And so that means the Lugol solution has somehow entered the dialysis tubing bag and interacted with the starch material on the inside and made it blue. Now, do we see any blue color in our distilled water Lugol solution? No, we don't see any blue color here. So it's indicating that none of the starch has left the bag and the starch remains in the dialysis tubing, which makes sense to us. And we also want to see if there's any glucose solution in the Lugol. Glucose in the distilled water. So I'm once again going to take my test strips, and we're going to do the same thing that we did last time. Okay, let's take a reading on our glucose test strip. This looks to be around 100, I think 300 is a little dark. So outside of our bag, in our flask and in our beaker that we put absolutely no glucose in, we are finding evidence of glucose. It's right around 100, maybe 200 milligrams per deciliter. So I'm going to write that down so that we are able to sort of record what's happening. And that's it.